name is Carla-Serena. I am a third-year engineering student at UnilaSalle. And now I am with my lab partner, Carla. Hi, Carla!
Hi everybody, I am Carla and I'm Serena's lab partner, as she previously said, and I am also a third year engineering student. And as third year student, we have an electronics project, and this year's project is to build a robot that is able to run through a labyrinth as fast as possible. So the object of this video will be to show you the whole process of building the robot and writing the code and testing it to make sure that our robot is functional.
So in this part of our video, we are going to show you the material we use for our project. First, we have an Arduino Nano and the support. You can see sensors are already connected. We have a battery and a USB cord. We have two servo motors and many wires and sensor for measuring distance.
We also have a bunch of screwdrivers, a rubber band to wrap the wires around the sensors, one pliers to cut the excess wires, a steering ball, two wheels, our frame and our screws. Okay, so now the first part of the assembling is done. The battery is inside the frame and we have mounted the wheels and the motors on the frame too. And then we are going to go to the next part, which is mounting the Arduino card with the rest of the circuit. In this part of the code, we begin by including the necessary libraries: wire.h for I2C communication, VL618.0x.h for the distance sensors, and servo.h for controlling the motors. Next, we declare three VL6 sensors, one for the left side, one for the center, and one for the right side of the robot. These sensors will be used to detect obstacles and help the robot navigate.
We then define the GPIO pins used to control the shutdown mode of each sensor, as well as their E2C address, which are essential for distinguishing them on the same communication bus. After that, we define two servo motors, the left and right motor, that control the robot's movement.
Finally, we set detection thresholds in millimeters. The constant seuil mur, juste mur idéal, and tolérance represent the wall detection limit, the ideal distance from the wall, and the acceptable margin of error. This setup forms the foundation for the robot's perception and motion control. In this section, we define the movement functions of the robot. The servo motors are controlled through angular values, where 90 degrees corresponds to a stop position. A value lower than 90 makes the motor rotate in reverse, while a value higher than 90 makes it move forward. Since the two wheels are mounted in opposite directions, it is necessary to invert their rotation speeds to ensure synchronized motion. For this reason, in the avancé or move forward function, The left motor is set to 70 and the right motor to 110.
The following functions define different turning behaviors. The tourner gauche petit and tourner droite petit functions correspond to small left and right turns, respectively achieved by slightly varying the motor speeds. The tourner gauche 4 and tourner droite 4 functions perform sharper turns by increasing the speed differences between the two motors. Finally, the arrest function stops the robot motion by setting both motors to 90 degrees, bringing them back to the neutral position.
This is the setup function of the code, which purpose is to initialize every parameter that will later be used by the Arduino maker and the code to help us navigate. Here we are inside the main loop of our robot's program. This is where everything happens in real time. First, the robot reads the distance from 3 sensors, one on the left, one in the center, and one on the right. These sensors help the robot understand its surroundings and detect how far it is from the walls. The program then displays those values on the serial monitor so we can keep track of what the sensors are detecting as the robot moves. Next comes the logic called wall on the right, which controls how the robot reacts depending on what it senses.
If the wall on the right is at the perfect distance and there is nothing in front, the robot simply moves forward. If it gets too close to the wall, it gently turns left to move away. If it's too far, it turns right to get closer again. And if the robot loses track of the wall, meaning it doesn't detect anything on the right or in front, it makes a sharper right turn to find the wall once more. Finally, there is a small delay at the end just to make sure the robot movement stays stable and smooth.
As we can see, our robot runs through the labyrinth quite effortlessly, even though we can see a few bumps. However, during our process, we have encountered a lot of issues, such as with the reading the distances with the sensors, and also mounting the Arduino card, as well as mounting the wheels on the servo motors.